From towering skyscrapers to intricate smartphones, engineering marvels rely on a fundamental element, joints. These crucial components connect different parts, enabling structures to function as a cohesive whole. Without joints, complex assemblies would be impossible, and our world would look very different. Imagine a car without hinges on its doors or a bridge without expansion joints to accommodate temperature changes. The consequences would be disastrous. Joints are the unsung heroes of engineering, silently ensuring stability, movement, and integrity in countless applications. Joints are essential in almost every engineered system. They provide flexibility, allowing for movement and adjustment between components. They ensure stability, distributing loads and resisting forces to maintain structural integrity. Joints also facilitate assembly and disassembly, making it possible to build, repair, and maintain complex structures with ease. In essence, joints are the unsung heroes of engineering, silently working behind the scenes to enable the functionality and longevity of the structures we rely on every day. Traditional methods of joint engineering, while effective, often face limitations. Designing a joint involves complex calculations considering factors like load-bearing capacity, material properties, and environmental conditions. Engineers typically rely on experience, hand calculations, and computer-aided design software to create these crucial connections. However, even with advanced tools, achieving optimal joint design can be time-consuming and challenging. One major limitation is the difficulty in predicting how a joint will perform under real-world conditions. Factors like wear and tear, vibrations, and extreme temperatures can significantly impact a joint's lifespan and reliability. Traditional methods often rely on approximations and safety margins, leading to over-engineered joints that are heavier, costlier, and less efficient than they could be. Additionally, the iterative nature of traditional design can be time-consuming, requiring multiple prototypes and tests before achieving the desired performance. Enter artificial intelligence, a game-changer in the world of joint engineering. AI algorithms can analyze massive datasets of material properties, environmental factors, and historical performance data to develop highly accurate predictive models. These models empower engineers to simulate joint behavior under various conditions, identifying potential weaknesses, and optimizing the design for maximum strength, durability,